Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 12 in the authentication module titled Password Brute Force via Password Change. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs. Do a search on authentication labs, and then go to lab number 12 titled Password Brute Force via Password Change. Alright, let's get started. This lab's password change functionality makes it vulnerable to brute force attacks. To solve the lab, use the list of candidate passwords to brute force Carlos's account and access his My Account page. And then you've got credentials for a regular user, the victim's username, which is Carlos, and a candidate passwords list. Alright, so the target goal over here is to brute force Carlos's password in the password change functionality and access Carlos's account. Alright, let's get started. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I am using the professional version because we will be using the intruder functionality, and that's heavily throttled in the community edition. So if you will be using the community edition, it will take a very long time to complete the lab. But if you want a quicker way without using the professional version, we will be scripting the exploit. And so you could just write a Python script that performs the exploit for you. All right, the first thing that we're going to do is click on My Account and then log in with the account that we were given. Let's hit login. And here's the change password functionality that's supposed to be vulnerable. So the first thing that I'm going to do is try the positive case, which is put in the correct password. And then let's say we change the new password to password and hit change password. Okay, so it says password changed successfully. And then we're going to go back and you stay logged into the application. So that's what happens when you put in the correct password. Let's put in the wrong password. So let's put in a wrong password over here and then a new password. Again, let's say password and a confirm password. So let's say again password. Hit change password and you get sent to the login page. Okay, so that's interesting. When we put in an incorrect password over here, so Peter, I had changed it in the first request, and so this is no longer the correct password, and we put in two identical passwords in the new password field over here, we get logged out of the application. So we have to log in again. So let's log in with the correct password, which is not Peter, it's password. Hit login. And we see that you have made too many incorrect login attempts. Please try again in 1 minute. Okay, so what's happening over here is that if you put in an incorrect password in the change password functionality, it will log you out of the application and then it will force you on a soft lockout of 1 minute. Now, if I need to wait 1 minute every time I try a password, that's going to be problematic because it's going to take forever to brute force, let's say 100 passwords. So 100 passwords will take 100 minutes before I can try all of them, which is unacceptable to me. So I need to find some kind of vulnerability in the application that will allow me to brute force the passwords. So hopefully the 1 minute is done. Let's try logging in. Hit login. And the 1 minute is done, so we successfully log into the application. Now my next test case is I'm going to put in a wrong password. So again, Peter, it's no longer Peter because we changed it. And then in the new password field, I'm going to say password 1. And then in the confirm new password, I'm going to say password 2. And then click on change password. Okay. So this is interesting. When I put in an incorrect password over here, what happened the last time we did this is that we logged out. However, right now, it's not logging us out. It's just saying the current password is incorrect. And the only difference between this request and the previous request that I was making is that these two passwords no longer match. And so there's some kind of logic flaw in the application that doesn't send you to the brute force protection mechanism if the new password 1 and new password 2 fields do not match. So this is interesting. This is what's going to allow me to bypass the brute force protection and brute force Carlos's account. So let's send this to repeater. Go down and let's keep these two not matching, but let's this time put the correct password and see the error that we're gonna get. So hit send and then let's render it and it says new passwords do not match. Okay, so let's make just a few notes so that we better understand this. So when new passwords match and current password is incorrect, which was this case over here. So let's say Peter. Sorry, when new passwords don't match and the current password is incorrect, let's hit send. Let's go to raw and render. We get an error saying current password is incorrect. Now when new passwords don't match and the current password is correct, which is this case over here. So password, hit send. It says new passwords do not match. Okay, so usually when it comes to an application, the first thing that you do is see if this is tied to the user session. So if this was implemented correctly, it should check if the password change request for this username over here is equivalent to the username that is assigned this session ID. If it is, the password reset request should go through, otherwise it should not go through. However, if this check is not done in the backend, then we could just change this to Carlos, and that's exactly what we're going to do. And then usually what you do is if there's no brute force protection on this, you just brute force this field over here by looping through a list of candidate passwords. However, we saw when we tried to brute force this list with these two passwords matching, we hit a brute force protection mechanism. And so we had to find the logic flaw, which is this one over here, in order to bypass the brute force protection mechanism and attempt to brute force Carlos's account. So let's send this to repeater. And actually, we need to send it to intruder. In intruder over here, let's clear. Let's make this a little bit bigger. And over here, we're gonna keep these different so that we bypass the brute force protection. And then we're just gonna brute force the current password. So let's add this and move this over here. Go to payloads. We keep it at simple list and then go to the application and click on candidate passwords and copy the list of passwords. Paste it in here and click on start attack. So now what I'm looking for is this over here saying the new passwords do not match. Now, I'm not sure if I changed the username, so let's click on one of them, go down, and we're still trying to brute force the password for our regular user, which we already know. So let's close this, discard, and go back to positions over here and change this to Carlos. And then start attack again. Now all of them are going to have the same error. Only one of them is going to have a different error saying that passwords do not match. So let's do a search on the length of the response of the request. And this is the only different one. So my guess is this is the password. So you can see over here, we've got the username Carlos and then the password, which is a bunch of zeros. The response over here is a 200 OK. Let's render it. And here we go. It says the new passwords do not match. So that means that we've hit this case over here, which is that the new passwords don't match, but the current password is correct. So the password for the Carlos user is this one over here. Let's copy it. And then just log into Carlos's account. So let's go in my account, log out, my account again, and then go to Carlos and put in the password that we just brute forced, hit login, and here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability using burp intruder. Now let's script it in Python. Let's close this over here, discard, and move this all the way over here. Save this. And the first thing we're going to do is import all the libraries that we need. So the request library, the sys library, and the URL lib3 library. Next, we're going to disable insecure request warnings. So URL lib3 dot disable warnings, URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy setting because we want all of our requests to be sent to burp. So all of the HTTP requests should be sent to HTTP 127.0.0.1 port 8080. That's where burp is running. And then all of the HTTPS requests should be sent to HTTP 127.0.0.1. And again, port 8080. All right, this looks good. Next, let's call our main method. So if name is equal to main, then call the main method. And for the main method over here, we're going to say if the length of the command line arguments is not equal to 2. So if the user ran it incorrectly, then we're going to print the usage instructions and the example instructions. For usage, we've got the name of the program and the URL of the application and the name of the program we take from the command line argument. For the example instructions, we also have the name of the program and then just an example URL. So let's say www.example.com. And the name of the program we also take from the command line argument. And then we exit the program because the user ran it incorrectly. Now let's assume the user did run it correctly. The first thing we're going to do is create a sessions object. So request.session. And then we're going to create a URL variable and take that from the command line argument. So sys.argv1. And then we're going to call a function called access Carlos account that takes in the session object and the URL. Now this is a custom function that we need to define ourselves. So we're going to say def access Carlos account, which takes in the session object and the URL. The first thing it's going to do is print a statement saying that we're logging into our regular user's account. And to do that, we need the login URL. So that would be URL plus the endpoint to login. So let's go to burp and go to proxy. And this is the endpoint to login. So it's /login. And then we need to set the parameters for the request. So login data is equal to the data that it takes in, so the username and password. Now this is for the Carlos user, but we need to do it for our regular user account. So the credentials that were given to us. So we'll say username, that's equal to the account that was given to us, and then password is equal to the password that was given to us. All right. And then we just perform the request. So r is equal to s.post, the login URL, data is equal to login data, verify is equal to false, and proxies is equal to proxies. So what this does is it logs into the regular user's account so that we have an authenticated session in order to perform the change password request. So this is an authenticated exploit. And so you do need an account on the application that is able to give you a valid session so that you could attempt to brute force the password of another user. So the next thing to do is print another statement saying brute forcing Carlos's password. And for that, we need the change password URL, which is equal to URL plus the endpoint to change password, which is this one right over here. Let's copy that, put it in here. And then we also need the change password data. So the data that is taken in the request. And that's this over here. And actually, before we do that, that would depend on the list of passwords that we have. So before we do that, we need to read the list of passwords. So what we're going to say is with open. So we're opening a file called passwords.txt and we're reading it as f. And we're going to say lines is equal to f.readLines. So passwords.txt is a file that I already have saved in my directory over here, and it's just a list of candidate passwords that the application has provided for us. So you just need to save it in a file called passwords.txt. And then from there, we're just going to loop through each password. So we're going to say for pwd in lines, the first thing that we're going to do is strip the new line from each password so that it doesn't cause issues for us in the application. And then we're going to use this over here. So let's remove the comment. So change password data is going to be username is Carlos. And then current password is whatever the password is, which is PWD. So we're just going to say PWD. And then new password. We'll just keep it at password 1. And then new password 2. We'll just keep it at password 2. Okay, this looks good. Now we just have to perform the request. So we're going to say r is equal to s.post. It takes in the change password URL. It takes in data is equal to change password data. Verify is equal to false because I don't want to verify TLS certificates, and proxies is equal to proxies because I want my request to go through burp. And then what we're going to do is we're going to check the response. So we're going to say if this string over here, so let's copy this string, is in the response, which is r.text. Then we found Carlos's password. So we're going to say Carlos PWD is equal to PWD. and we're gonna print found Carlos's password, and we'll print that on screen, and then we'll break out of the loop because we already identified Carlos's password. Now the next thing to do is just log into Carlos's account. So we're gonna say if Carlos PWD is not empty, then we could log into his account. So just say login. But if it is empty, then we're just gonna print could not log into Carlos's account, and we'll just exit the program because failed the exploit. All right, but let's assume that Carlos's password is not empty. Next thing we're gonna do is just log into Carlos's account. So login data is equal to, again, username and password. So I'll just copy this. In this case, the username is Carlos. And the password over here would be the password that we just brute forced, which is Carlos PWD. And this is actually not, it could be PWD or it could be Carlos PWD, it doesn't really matter. And then we just perform the request. So we're going to say R is equal to request.post. It takes in the login URL. Data is equal to login data. Verify is equal to false, and proxies is equal to proxies. And we just need to confirm that we properly logged in. So we're going to say if logout is in the response, so r.text, then print successfully logged into Carlos's account. Otherwise something happened, and so we need to print could not log into Carlos's account. And we exit the program. Now over here, I'm noticing I'm printing the same error in this case and in this case. So over here, it tried to log in using the Carlos password that we found, but it couldn't log in, so the error is correct. But over here, it reaches this else statement if we didn't find Carlos's password. So instead, I'm going to change the error and say, could not find Carlos's password. All right, let's save. Hopefully there's no errors over here. Now, before we run it, it's likely that the application timed out. So let's open a new instance and then go to terminal, new terminal, Python 3, and then the name of the lab and the URL. So let's copy that, paste it in here, remove the trailing slash and hit enter. So far so good, and I do get an error. So line number 19. Okay, so this should be in single quotes. Let's save it, clear. Clear. And run it again, hopefully no other errors. So it's telling me that it's brute forcing Carlos's password. If we go to our proxy, we should see the requests being performed, and they are. So over here, it's performing the requests, and it's looking for this specific string over here. And it's never going to find it because I wrote this incorrectly. And I'm not sure how this happened, so let's remove this. And the string should have been new passwords do not match. Let's copy this, put it in here, and save. So let's get out of this because it's never going to find that string, and run it again. And so this should work. It should find the string over here, new passwords do not match. Once it finds it, that means it found Carlos's password, and it's going to try to log in using Carlos's password. And here we go. It found the password. The password is Dallas. And you could see here it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually using Burp and then scripting it in Python. In the next lab, we'll look at another case of a broken authentication vulnerability.